In our economic lives, each of us is trying to do the best we can to satisfy our needs and wants within the constraints we face. As we say, we are maximizing our utility subject to our budget constraint. We are each acting in our own interest, and those actions manifest into a competition for the scarce goods and services available. We all need to eat, but there's a limited amount of food. How do we decide who gets what? The answer is demand, a market force which represents consumers. To get a sense of how demand works, think about what you would be willing to pay for certain things. Gas prices are often observed with a distressed look on our face because many people are reliant on gas to get where they need to go. Even as gas prices rise, people still buy it, suggesting they were always willing to pay more than they had to. Consider the diamond water paradox. Diamonds are a luxury item and they're very expensive to buy, whereas water is a necessity and it's extremely cheap. Why is this? Surely if we had no other options, we would be willing to pay a lot more for life-giving water than an unnecessary diamond. But we don't have to. I always think about the internet. It's pretty expensive to get internet in your home or on your phone, but if the cost doubled, would you still pay it? What if it tripled? I think I still would. I mean, what else am I going to do? Not have internet? For each of these goods and services, we all have a secret number, a maximum amount we would be willing to pay for it given our constraints. So where does this number come from? Previously, we have studied the theory of consumer behavior that underpins economics. Let's see if we can use this theory to understand a consumer's willingness to pay for something. Consumers are said to maximize their utility subject to their budget constraint. We can express this both mathematically with a utility function and a budget constraint, and graphically with indifference curves and budget lines. Let's define our utility function and work out a general solution to the consumer's problem. We will say that a consumer's utility is given by the function x1 times x2. With a utility function defined, we can use the optimal consumption rule to solve the maximization problem. Previously, we did this by also inputting values for the consumer's income, y, and the prices for x1 and x2. But we don't need those numbers to run through the algebra. Let's start with the optimal consumption rule, which says that the marginal utility per dollar should be equated between the two goods. We learned previously that the marginal utility from x1 is equal to our value for x2, and vice versa, which we can plug into our optimal consumption rule and rearrange into this equation, which defines the ideal mix of x1 and x2 for this consumer. Our next step is to plug this back into the budget constraint and solve for x1. Before, we had numbers to plug in along with it, but we don't need those numbers to proceed. We can substitute our equation into the budget constraint and then work through the algebra just the same way. The price for x2 cancels out in the two places, and we end up with y equals 2 times the price of x1 times x1. If we rearrange that so that x1 is on the left-hand side of the equation, then x1 would be equal to y, income, divided by 2 times the price of x1. The nice thing about having this solved this way is that now, if I did give you numbers for y and the price of x1, you could plug them right into this last equation to find out the optimal quantity for x1, instead of going through the math again. This general solution works for all values of y and p sub x1. In fact, that is exactly what demand is. We can graph this final equation where we have the price of x1 on the vertical axis and the quantity for x1 on the horizontal axis. Demand is the relationship between the price paid and the quantity purchased by the consumer. Given some price for X1, we can just follow from that price over to the demand curve and then follow from there down to find the quantity demanded at that price. In other words, the demand curve tells us how many units of a good a customer will buy given the price. But if we rearrange the demand equation, we can think of this another way. We can rearrange the equation so that the price is on the left-hand side, which is nice and easy with this equation. Looking at it this way, where the price is the dependent variable being determined by the quantity of X1, we can interpret demand as the maximum amount we would be willing to pay for a certain quantity of the good. Indeed, demand represents what we are willing to pay for something once we have considered all the trade-offs associated with buying it. We can see the direct relationship between our consumer maximization model and demand by thinking about what happens in each graph when the price changes. Let's increase the price of X1. In the graph on the left, increasing the price of X1 rotates the budget line inward, and our indifference curve must fall in order to meet it at a lower quantity of X1. For the graph on the right, a higher price means movement along the demand curve. The dot on that graph is like a car driving along the road of demand to its new destination at the higher price and corresponding lower quantity of X1. As we keep raising the price of X1, we get the same kind of reaction on both graphs. And of course, if we reverse this process and lower the price of X1, the consumer increases the consumption of X1 on both graphs. Hopefully, this animation helps connect the ideas of consumer choice and the consumer demand curve. The demand curve is like a summary showing us the consumer's optimal choice for every possible price. The key takeaway, though, is that from consumer choice, we can derive demand. Demand represents the relationship between the price of a good or service and the quantity that the consumer wants to buy at that price. Demand shows how much we are willing to pay for each unit of the good, which is determined by the marginal benefit of consumption. That is, the demand curve is the summary of what the best choice is given the price of a good. And so movements along the demand curve tell us how much each additional unit of a good is truly worth to the consumer. Next, we'll see how our individual demand aggregates into market demand.